Okay, so today I'm going to start off talking about electric and magnetic fields, which you've learned a bit about, but I want to use them as a way to start talking about something else.
다 키란수 남준이 코드에 탄다 로다 카블링기 라올라이디 코드에 로스 아니 디다 데웬 가주 탄다 조시카시슬리 레스 탄다 디간 두기인스.
Okay, so all charged objects have electric fields.
뉴디 디르도 쿠르요베 ngobo 차창마라 아니 로기 라와 요레슬란디 니바디.
So the question is where do magnetic fields come from? And magnetic fields are basically just electric fields, but that are viewed from the point of view where the field is moving. So they're basically moving electric fields.
다 단당조 카블링기 라와라나 칸디질 라그라나 지단 쇼이나 로기 라와랑 레스 네타당 로가 친 쇼이나 다 로기 rawa joredi yogu chiwa kujotang wa dende doji chade res kablingi rawa ledi.
Okay, so the reason I want to talk about all this is today I want to talk about the concept of spin. And we talked a lot about spin the last couple of days, and I want to talk about where does spin come from and what is spin. So that's sort of the big theme for today.
Ta taringzo kharito shian lana rangkhor se jua spin digal shi is spin le rangkhor le di khandes chungre le jura and di khandes lagur le di korshi is.
So what I'm going to do is I'm going to start by giving you a classical view of what we think spin is, and then I'm going to tell you about what it really is like in quantum mechanics. Okay?
Ta tanda rangkhor se jura di nganzu suyun gi shedan jura rangkhor lana dendi jil lagi reslan di korshi thana shi tanda nganzu chidu ngokam rikwan la rangkhor lana khandijil shagi me di koryan shi is.
So if we imagine, so this is what it is in classical physics. So if you imagine an electron, if we pretend an electron is actually a little spinning ball,
당주 lokdul do chasha na khande dojil chasha lana polo ji rangkhor chidio dende polo dojil chasha gros.
Okay, so an electron is a charged object, meaning it has an electric field, right?
당주 electron lokur se dikhare koran la khuryo ro khuryo ngobuji chadyo diladu gala ani koran la ani thanda lokur gonda lokdul dela ani loki rawa diyo res.
So all magnetic fields in the universe come from the fact that electric fields are moving, or so the people observing the electric fields are moving. So that's where all magnetic fields in the universe come from.
Diladu loki kablengi rawa la dinganzo khari korshi goringela loki rawa di yogu chede di lagora di toship chung res observe chulana taship chung da toship chung lawra dende toship chung du gala an nganzo gi tanda kablengi rawa la di dende chung di shi res.
Now, this is a magnet.
Ta di ngarja jira kablen la nare ngarja la nare dende jiros.
This isn't moving, so where does its magnetic field come from?
Ta di kujo tang mindos khorangi tanda kablengi rawa di khandesle res.
It comes from the fact that at the very basic level, if I were to sort of zoom in really closely, all the little atoms and electrons and things inside this are spinning.
Ta dus ta do ke thungu mindos de yoro thungu dos ani yakpochini ma draw ena thing sabu draw ena khari re di dutain da du din so group shaw ras lokdul din di re ta ena khachire re rangkhor gya de res.
And specifically, in fact, actually, all right, so here's a marker. This is not magnetic. It doesn't stick, right?
Di kablengi rangshi yore di la yomarwa nyugu dil chashana digal jargum dos ma sa yung dos.
But all the things in this are spinning as well. So all the electrons and all the atoms and things are spinning in this as well. But this doesn't have a magnetic field, and this does have a magnetic field.
Ta yine khare chikpa chagdlana di nanglo khare duten da lokdul da changma yoro thana shi koran nanglo tawane ge duten da lokdul re tawane khachire rangor che de yores. Ta yine ngobu dil chashona di dila khabling gi raw yo marwas dila khabling gi raw duas.
So the question is why does this one stick to the board and this one not stick to the board?
Ta thiwa di kharli gi lawaina di ngobush do di jargi duas karbang dila di nyugo di jargi min duas masale so di kharchini res.
And the answer is that it's because all of the electrons and atoms and things in this are spinning in the same direction.
Kais na dinal chashawaina dina ngob thanda gujo chi rangor chigi orlarwa di sangma chok handes chigi orlana chok chigla rangor kyagi res rangor chigi res.
So this is what a magnet would be, whereas if I had
ta khablin nal chashawaina thanda ngarja ro chashawaina rangor chidang pe shawaina dindes tungu res tindang di chok chigla rangor chiyo tungu do.
So something like this, they're not all spinning in the same direction, so this would not be a magnet.
Ta dila tawaina khajo chigla rangor chig do sangma di chashawaina di kharina yor lawaina ngazo khabling gi rangshi jo do thanda ngarja dinde chashawaina dinjo chayo res khabling dinde nal di na khabling member dinjo yora di ndu kala rangor tawaina chikbar do logarish chikbar min do dinde yores dinde yo aina rangor chidan dinde ngobo jimba ina an khabling member chayo yores di.
So each of these spinning particles behaves a little bit like a bar magnet. I think you guys know what a bar magnet is, right?
Tanda ngarja damida mangbu thonyu ra khiranjo dinal chi khare thushi narmush do dil bar magnet liyo dinde khiranjo thonyu us. Yes they know.
Okay. So like a bar magnet. So a bar magnet has a north pole and a south pole.
Ta tanda nganjo di ngarja thushi narmush jo bar magnet se di dina cha shawana changne dalhone nani ni yor wastila.
And actually, one of the interesting things about magnets is that you never ever in nature, you never see just a north pole or just a south pole. You always see them in pairs. So if I took a bar magnet and I cut it in half, I'd have two new magnets, each of which had a north and a south.
Ta ngarja na mixe chi khari thoyer se lainas tanda ngol khar ngarja chi ro dinal khardo changne dalhone lan do ta ngarja indu wala ngarja insa jela changne dalhone lani ne ni ye bares khadu imbaina ta peshana ngela di chang dalho lan ni do di chawaina khar chagre thumbu nil chagra dila de di khorana la ya changne dalhone lani chadu res de.
And the reason for that ultimately comes down to the fact that magnetism really comes from spin, and anytime you spin something, it immediately gives you two poles, right? So there's a spinning point here and a spinning point here. So anytime you spin something, you always have two poles. So that's why you always get you never see one pole by itself.
Tanda rangkor khorana tawaina chashawaina khare rangkor lo du skora gyo shigora so ne dil tadu gala ni yo bare dos changda ne lani dishi du rangkor yo du gala ni yongu yo res khaduna.
So this is what we expect from just the behavior of regular old magnets, of classical magnets and things like that.
Dila du nganju chidangi ngarja yora so yu keje she de ngarja di kor she res di tangchi dinala.
Now the question is what happens if we have something like this and the particles that we send in here are electrons. So let's say we have let's say these things are all electrons.
Tangwel taje tharan chero dinala ta tananga ju du tangir la ro du di kesi log du limba inas.
And the question is what happens? We would expect the same thing to happen.
Ta dinala kesi log du tangwaina dine tangyora du di tangwa di log du tangwaina ani del khare chungures.
But in fact, it's not what happens. What you get is all of the electrons either go up here or down here.
Dangola dul tang dugal dinde chungur la ra ta tanda log dul tang waina khare chungures la ra ta ngaju choba chona ngoi di rangja yungures sam gi roas dinde chungu yo mares ta log dul tang waina khare re chachik del dugures ani yamena ma dinde dugures
And it
ngoi di ro tungu yo mares.
And it doesn't matter where they go in here. So you could put one here, 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 have it spinning this way, having spinning that way, spinning this way. It doesn't matter where you put it in this magnetic field. The electrons will all either end up here or here.
다 모인디 차샤이나 하리레 갑랭기 라왈 빠베 아니 단다 초 가조 띵구 도스 다 단다 록둘도 차샤이나 딘데 요 마레스 딘네 땅와이나 가지리 야나 델라 투구 레스 라야나 델라 리요 레스.
And because I know there will be a question about this, I will say you can do the same thing with ions, so individual ions of an atom. You can do them with specific atoms. In fact, the original experiment was done with silver atoms, and silver atoms are actually charged because there are 47. They have a little magnetic field because they have an uneven amount of electrons in them. And because they spin. So you can do this with electrons, you can do this with protons, you could do this with atoms, with ions, anything really small.
다 디가라 두 컨데지네게 딱지 치두 레스 탄다 디 차셔나 록둘 케시사 타나시 두테 아니 포둘 카리마이나 치두 레스 아니 디 딱지 디직 타나 간조 응위기 두텐도 덴델 치요레스 응위기 두텐라 두 코란라 로쿠르 요도 차디 레스 칸라나 코란 두텐 코란나 타와나 로쿠르 요 카레 록둘 요라 록둘 차냠부 주요 마레스 제자니 코란기 로쿠르기랑 시도지 차디 레스 응위기 두텐디.
And all the really small stuff does this weird thing where you only get two things out of it.
Dila du de kensaoj doas dina ta du gala ni thungu doas tumdedi.
So, what kind of a conclusion would you draw from that? So that's really weird. What might you think is the result of that? So, what would your mind say if somebody gave you that data and you're like, wow, what do I think about that? What do you think about that?
Ta ta je dinde ji chini dinde thun res la ro dumde. Dila du gala ani kheran la thangdo dinde styo ai nasra. An kheran ju samlo na khari lesa res. Ta dinde logdul tang re de yana yana mali la ro. Dit kheran ju thangdo dite ro. Dite de ni one thing maybe like if you look at this one, the particles are attracted only by the top magnet, and when you look at this part, the particles are attracted only by the down magnet.
Okay, all right. So
so he's saying it may be because of the shape of the.
Yeah, it's actually not because of the shape. I mean, here's the thing, because the shape is the same here and it's the same here, but if you throw bar magnets into this, it doesn't do that.
Chikwarelas if dida thanda dela tendo dida ngen di chikpa imbas lab girang shires. So because electrons have wave nature.
Maybe.
Easy res. Like khachite? So we talked about entanglement. So maybe because these two are entangled.
Well, so meaning these two?
Yes, these two. One is up and one is down.
Yeah. So you're getting closer. Yes.
Oh, newly to this.
This is good. So the way we think about this is that we think about if you only get them up here and down here, then this must correspond to the fact that some of them are spin up and some are spin down.
Dila du khashe khari yore rangkor khenche ani khashe rangkor di tur layo di tungi roas.
But the question is up and down with respect to what? Like up and down to me is this way, but up and down to something like this is there's up, there's down, right? For me, up is that way, that's down. So as far as this goes, the way we think of it is we think of this is up and this is down. But this means something really important. This means that spin isn't like regular magnetic things. Spin is something completely different. It's not like a classical thing that's spinning on its axis. It behaves completely differently. This is really weird. And in fact, what we think, the way we think about it is we think of spin now as an inherent property like mass or electric charge or something like that.
다 단당 아주 랑콜란 계지 시기요라스 순균이 계지 시도알 랑콜라도 카르 소신치갈 코르디오나 시기요라스 디고르 시기요 마르다 단당 아주 스핀 라이스도 랑콜라디 칸디질라고 라와나 랑웨기 계주에 된 요라 차샤와나다 코랑기 되셀라나레 니 로기 쿠르라나레 딘줄 차샤기요레스.
Now this is a really important thing. So what that means is we think of individual particles as if they're spin up, it's like saying they have a specific charge or they have a specific mass, meaning that we assume that that can't really change very easily.
Diladuta spin up leido rangkhor ye gang dilan disara diladugala di khandis shigur lawana korala deselana re lokurlana re ngechen ju resra di yo maseni gwa ya dolaw tendi ju res.
So just to give an analogy of the sort of the different ways that we think about it. So in the classical objects, the rotation and the spin is just like a way of counting how fast something's moving around in a circle. So if I'm doing this, that's a different spin than if I'm doing that, right?
So yungi rangkhor keje shona di roales rangkhor chioche ani kyose dilapak birali gi ras ko kora khagas ke gi me dila.
And I can have any value of spin because that spin is not part of me. That doesn't make me who I am.
Diladu rangkhor chie jura diladu gala ni ngaran drupe gita kejo laura dendi ji chagi yo maras di chila yo roji chadi gi res.
But a quantum particle, if it's spin up, that's a part of its personality. It is if it's spin up along a particular direction. So let's say this is this particular direction, so that's the way it's pointing. If it's spin up along that particular direction, that's part of its personality, and it's always, we assume, it should always be that way along that direction because that's its sort of, you can think of it, that's its nature.
Tatanda diladu spin la dike shi da apladi diladu gala ngazu miro na personality le yo dinang shi koran du koran ge rangshi gi keju roji chadi ge res khadu na yo ba res koran la.
So spin is a property like mass and like charge and like, you know, so for us as human beings, like our eye color, perhaps our height, you know, once we are adults, things that make you you.
Diladu mila du mi personality da mi gi khado da trai khado da di changma ta chugi ras dinang shi thanda ngazu du na ke shi du gala thanda duise da lokur da di changma spin na ligi res koran gi rangshi gi keju roji chadi ge res.
And again, I want to emphasize the reason that scientists think this is because this doesn't act like this.
Tachi kharir lawana di shiju tendan da dida tagminduas.
So here we assume the behavior is like you're doing something, but it's not part of the personality. It's just how it behaves to some external thing that's happening. Here, it seems that no matter where you put the particle, it's either going to end up here or here, which means it's got to be something inherent to its personality.
Ta dinal tawana chi shugil pepe yama dwejura diro chagi ra susu rangwi gi kejo roji thongyo ma res dinal ta di niba dil chashawana di logir tangdu gala yana ma dur lara di rangwi gi kejo ta ma shijo te ma ro di chadi res.